Good morning, everyone. We have today the smallest chapter in the course, which is size separation, how to separate coarse powder from fine powder. Mainly, we have two categories or two methods for size separation. The first category is size separation by sieving, and the other one by fluid classification. By sieving, using different sieves. So it depends on the size of the particle. If the size is bigger, if the particle is bigger, it will be kept on the wide sieve or the sieve with wide opening, and if the size is smaller, it will be kept only on the sieve with a small opening, and so on. The other method is fluid classification. Here you are not talking about a powder, you are talking about suspension. If you suspend powder in water, and some of this powder are fine powder, some fine particle, and the others are like coarse particle. So by default, the coarse powder are bigger in size, and so it will be heavier in weight also. Heavier in weight, it means it will have higher sedimentation rate. It will sediment first. The intermediate powder will be sediment with a slower rate and sediment later, and the lighter powder and very fine powder will remain suspended in the suspension. That is called the fluid classification. So we are classifying the powder based on their weight after suspension in a fluid or liquid. We have mainly two types of sieves. The normal sieve, that what we know and saw in the lab also, which is on the left side, which is made of cross-linked metal wires forming a network or forming the sieve opening. And each sieve also is having a sieve number. And the meaning of the sieve number is the number of opening or number of meshes in 1 inch. And you know the inch equal 2.54 centimeter. So for example, if we have sieve 10, it means that we have 10 meshes or 10 opening in each inch. Sieve number 20, it means we have 20 opening in 1 inch. So that's why sieve 100 is having very small opening compared to sieve 10, because sieve 100, it means we have 100 opening in every inch, while sieve 10 having only 10 opening in a single inch. So sieve 100 is smaller than sieve 10, or having smaller openings. On the other hand, we have another type of sieves, which is called perforated blade sieves. This type of sieves is formed of a metal plate with pores inside the plate, and this pores is usually circular rather than being rectangular or squared. So the advantage of having a circular opening, it means that there is less possibility of powder accumulation in the sharp corner of the squared opening, while this circular opening easy to be cleaned and less possibility of aggregation of powder inside the sharp corners. So it's better, and also usually this type of sieves are stronger than the normal sieve, so it is less susceptible for distortion or distraction even if you add pressure on it during sieving. There is something important that we have to take care of it during sieving, that we shouldn't add pressure on the powder during sieving. We shouldn't press on the powder while sieving, because if your sieve is having large opening, and especially in presence of any binding agent, or even if the powder is sticky by default, so the powder will adhere to each other, lead to a powder fusion and granulation. So now we are making granulation, not size separation. On the other hand, if your sieve opening is very small and under pressure, so the powder will be grinded due to this pressure and pass through very small opening sieve like the extrusion mill, and this will lead to a size reduction rather than also size separation. We have four methods of size separation by sieving or to facilitate sieving. Four ways. The first one is agitation, second one is brushing, third one is centrifugation, and the last one is wet sieving. Agitation can be classified into two subclasses. One of them is oscillation and the other is vibration. The difference between oscillation and vibration is very clear. Let's imagine that you have your mobile and your mobile is vibrated, so the vibration is happening, but your mobile is still almost kept in the same place. It is not moving forward and backward. That is vibration, while oscillation, let's imagine that you are moving your mobile forward and backward. That is oscillation. So in case of oscillation, the sieves are moved to a certain distance forward and then backward again. While in case of vibration, the sieves are vibrated, but it is not moving, it is kept in the same place. The disadvantage of oscillation that there is some fibrous material like the plant stems or leaves. If the sieves are moving forward and backward, they will have tendency to pooling or to aggregate and form balls. While in case of vibration, there is less tendency or less probability for this fibrous material to aggregate and form a big spherical aggregate. The second way used to accelerate sieving is brushing method. We use the brush to move the powder on the surface of the sieve, prevent aggregation, and even after sieving to clean the meshes and clean the opening, prevent aggregation of powder in the sharp corners of the opening. We can use that in a small scale or on large scale. In a small scale, we are having the normal sieve and the brush is moving in a circular motion or horizontally and rotate horizontally inside the sieve. While in case of large scale, if we have 10 kilogram, we cannot use very big sieve in terms of the diameter of the sieve, but we can use a cylindrical sieve, very deep sieve. So in this case, the brush cannot move horizontally. It should move, okay, in a circular motion, but at the same time, it should move up and down. It's something like mixing. We shouldn't leave any dead point. So the brush will circulate at a lower level and then move to the higher level and circulate, also move in a circular motion, and then move at higher and higher level and circulate, and then start to go down again and continue to move in a circular motion. So if you look at the motion collectively, it is a spiral motion, not really a horizontal motion. The third method to accelerate the sieving is by centrifugation. In case of sieving by centrifugation, the sieve here is inverted. The sieve opening is not in the bottom, the sieve opening on the wall as you see in the image. And the sieve is connected to a vertical axis, rotating around this vertical axis with very high speed, maybe 5,000 RPM, 10,000 RPM. So by centrifugation, everything, all the powder, either coarse or fine, will be thrown on the sides, on all sides. So, and under the pressure of centrifugation and under the pressure of forcing the powder will be forced to move inside the opening. But of course, not all powder can move. The fine powder only can escape from the sieve opening, and the large powder will remain inside the sieve. The last method for acceleration of sieving is wet sieving. Rather than having a powder and the powder may aggregate, may accumulate, may block the opening of the sieve, we can suspend the powder in a solvent that cannot dissolve it, of course, and then we can make wet sieving. We can pour this suspension or add this suspension onto a sieve. So again, of course, water will move and the fine powder inside the water will move through the sieve opening, and the coarse powder only will remain on the sieve surfaces. It has some limitation, of course. The main limitation that maybe you cannot find a suitable liquid that will not dissolve the powder. Maybe the powder is soluble in water and soluble in alcohol and soluble in so many organic solvent. So you cannot use the same method for all type of powder. But the advantage is reducing the possibility of powder aggregation and clogging or blocking the sieve opening, because the powder already is dispersed inside water or inside the liquid. So after size separation by sieving, the other batch or the other category is size separation by fluid classification. And under fluid classification, we have two main methods. Fluid classification by sedimentation and the fluid classification by elutriation. And we have also two types of sedimentation: simple sedimentation and continuous sedimentation. So again, the chapter is going like that: size separation either by sieving or either by fluid classification. Under sieving, we have four methods that we mentioned before, and under fluid classification, we have fluid classification by sedimentation and by elutriation. Under sedimentation, under fluid classification by sedimentation, we have simple sedimentation and continuous sedimentation. Simple sedimentation, it means the simplest thing that you can do in the lab, just by, if you have a suspension with coarse and fine powder, just allow it to sediment, allow it to settle down. So the coarse powder will settle down while the fine powder will remain suspended at certain time. That is very simple, but it has so many disadvantages. First one, it is a batch process. It is not continuous. You have to wait and put a suspension, keep it for a certain time, and then take the supernatant or take the upper part of the liquid, which will contain fine powder, and the lower part of the liquid will contain, or the precipitate will contain the coarse powder. The second disadvantage is it is indefinite. I mean, unclear how much volume should I take from the upper layer. What is the volume of the upper layer? If your suspension is 100 milli, shall I take 10 milli from the surface and consider it as the volume containing the fine powder? Shall I take 50 milli? Shall I take the whole supernatant and consider all the liquid of the supernatant having a fine powder? Or and also where is the coarse powder? So there is no cutoff that you can follow to separate the fine powder from the coarse powder. That's why we have the other method of sedimentation, fluid classification by continuous sedimentation. In continuous sedimentation, we have a tank, and the lower part of tank is partitioned. You can make 2 partition, 3 partition or more. The simplest one is having 2 partition, and the sediment, or sorry, the suspension is introduced from the left side. So the suspension will be forced, will be bumped from the left side, as you see in the picture down, to pass through this tank, to fill this tank, till it exit from the opening on the right side. So the inlet on the left side and the outlet on the right side. So what is happening in between? The suspension now is under 2 forces, 2 perpendicular forces, mainly or almost perpendicular. The force which takes the powder down, which is gravity, and the force which forces the liquid forward, which is the bumping of the liquid. So you are bumping the liquid to move from the left to the right side, and the gravity is taking the liquid or the suspension down. So which powder will sediment first? Logically, the coarse powder will sediment first. So most probably the coarse powder will be collected in the first partition on the left side, and the fine powder will be collected on the right side. And if you have 3 partition, you can categorize the powder into coarse, moderate, and fine, or coarse, moderate, fine, and very fine if you have 4 partition in the bottom. The second method of fluid classification is elutriation methods. And even under elutriation, we have 2 subclasses: single stage elutriation and multiple stage elutriation. Elutriation, it means, the word elutriation, it means the movement of the liquid against gravity, against the direction of sedimentation. It means against gravity, it means from down to top, moving upward. So if you introduce your suspension, which is having a variable particle size, fine and coarse powder, if you're introducing your suspension from down on the left side here in the picture, so that is the inlet of the suspension, inside this column, so the suspension will start to fill the column, and of course in the beginning you have to close the outlet in the bottom. So the only outlet now is in the top, on the right side on top, which is the exit. So very simple, the suspension will fill the column till it reaches to the top, but which particle can be carried by the liquid against gravity to the top side or to the outlet? Only the fine powder. So the coarse powder, while the liquid is moving up, the coarse powder will sediment down. So now you have 2 fractions of powder: the powder which can be carried by the liquid against gravity and exit from top, and powder which cannot be carried by the liquid and will sediment by gravity, and it will settle down. At certain time interval, you can open the outlet and take the coarse powder. At the end, you can take the coarse powder. It's good and easy, but the only disadvantage that this method is having 2 fractions only: coarse powder in the bottom and fine powder carried to the top outlet. The last method of elutriation, or the second method, is multiple stage elutriation, where we have several columns. The first column is a narrower one, and then we have intermediate, and then we have the widest column on the right side. So the suspension will be introduced to the column number 1 in the picture here, then it will exit from top, then it will enter to the second column from bottom, exit from top, then it will go to the third column from bottom and exit from top. The idea here is that it depends on time, how much or how long the suspension will remain in the first column compared to the second, compared to the third. In the first column, because it is very narrow, very small, so the liquid will go up faster. So the suspension will not remain in the first column for a long time compared to the second and third. If the time is less, so only the very coarse powder will sediment in the first column. But after going to the second one, the liquid will take more time to fill the second column. So there is more possibility for the moderate powder to sediment in the second column. After going up and then going inside the third column, which is the widest one, the biggest one, it is like small, medium, and large. So inside the large one, the liquid will take more time to fill it. So you will have more time to sediment the fine powder. At the end, the very fine powder only can be carried up in the third column and exit from opening or outlet number 4. Thank you so much and see you on the next presentation.